We are going to go through the Pythagorean Theorem today. So with Pythagorean Theorem, if you took 8th grade math, you would have had some experience with it. You have completed Algebra 1 and possibly AFTA, and with Algebra 1, you did what we called simplifying radicals. Those taking an SOL test, that does come into play, but if you're actually using the Pythagorean Theorem in life, you probably won't be doing simplest radical form. So to save time today, I'm going to skip over the algebra review, but if you need to take the SOL, we will go back through and talk about this. So let's talk about the Pythagorean Theorem. And so where the history came from, back in the early Greeks, when they were building and in Egypt, they were building the pyramids, Pythagoras was studying what was going on, and he noticed that these rope stretchers would have 12 spaced knots, and they would do them in a nice design, and he would analyze that design. Well, the design that he analyzed, he took back and he researched it a little more, and he started to realize that there was a lot of math in what they were doing, even though they weren't physically writing down math problems. That's when a lot of you say, I'm never going to use math. You might be surprised how much mathematical thinking you do, even if you're not using math, physical math. And so he determined what they were doing were these 3, 4, 5 triangle situations, and that 3, 4, 5 triangles is what established him to go into the Pythagorean theorem. So this is just the history of it. Pythagorean theorem is used to find the missing side of a right triangle, and it can be any missing side as long as you have the other two. A and B are called the legs. Side C is what we call the hypotenuse. And for any right triangle, it's always going to be a squared plus b squared equals c squared. Some books will write it the opposite, c squared equals a squared plus b squared. And in geometry, we often look at it this perspective, even though you probably learned it in middle school as ABC. Oftentimes in geometry, I'll do it the other way, and it has a reason for that, and we'll talk about that coming up. So I'm on page 41. Let's flip to the back of the page. So at the top of this page, I do have 2 completed examples for you, just to remind you of middle school. So the first one, you were missing a leg. And so we filled in that a squared, b squared, c squared, a and b being the legs. It doesn't matter which one's x and which one's, or which one's a and which one's b. So I just put the x squared in for a, the 3 in for b, to make it 3 squared. And then the hypotenuse 5 was the 5 squared. 3 squared is 9, 5 squared is 25. Solving the algebra equation, subtracting the 9, getting 16, and then unsquaring by taking the square root. That's probably the step that gets left out a lot, is people forget to unsquare the value. And so it takes me to a value of 4. Here we have the 2 legs were given, and you were looking for the hypotenuse. So 4 squared plus 6 squared equals x squared. And so 4 squared is 16, 6 squared is 36. This time you're going to add them, get 52. Again, you need to unsquare it. Now you're going to see that I have it here written in what we call the simplest radical form. But for purposes of us this semester, let's take it to a decimal. So remember where the square root is. It's above the x squared button. So we press second, x squared, type in that 52, and you will get as an approximate 7.2. Now that you're beyond middle school, oftentimes you're going to be doing word problems. And so with the word problems, which is more like what you're going to have in life, I want you to take a minute, read this word problem, and draw a picture of what you think that problem is representing. So take a minute, pause, and draw that picture. Okay, so let's take a look at what you drew and what I drew and see how they compare. So I went and drew myself a little mini house here. Nothing fancy, but just to get the idea of a house. It says that the person is trying to get to the roof, so he leans a 16-foot ladder against the house. So here's my 16-foot ladder leaning against the house. The base of the ladder, meaning the bottom where you start to climb up the ladder, is 5 feet from the house. So here's the edge of the house, 5 feet out is the bottom of my ladder. And how high up the house would we stretch? What would be that height? Now, the one thing that's missing is we cannot use the Pythagorean theorem unless it has a right angle. So my hope is that whoever built this house built that house at a right angle. So that's an understood part of the picture that isn't part of the word problem. And so now we have this scenario where we have this right triangle, which is going to convert to a simpler looking triangle that's a right triangle in which we know the hypotenuse to be 16, we know one of the legs to be 5, and we're looking for the other leg. So then I can put this into my a squared, b squared, c squared scenario. So these being my legs, these are my a and my b. I tend to make x be my a when I have a leg missing. There's no rhyme or reason why it has to be. It's just what I do. So I have the x squared and the 5 squared as my 2 legs. And the 16 squared is my hypotenuse. So 5 squared is 25. 16 squared is 256. And my x squared, subtract my 25, subtract my 25. That's going to give me 231. And then please don't forget to always unsquare. So we're going to take the square root of 231. And for us, I just want to use an approximate decimal approximation. So I'm going to do the second square root, 231. And I get about 15, and my little smudge on my calculator, about 15.2. So what that says is if you are putting a 16-foot ladder against a house, bumping it out about 5 feet, you're going to reach about 15 foot in the air. So a lot of times you say, when am I ever going to use this? You might only have a ladder at home that's 8 foot. Well, how far up the house can you possibly get it if you know that you can only safely bump it out like 3 feet? So this really can help you get into like safety and thinking about, well, where can I reach with different scenarios of ladders and other things. So anytime the 3 numbers, A, B, C, that make the Pythagorean theorem work are all integers, meaning that there's no decimals or fractions involved, those are called a Pythagorean triple. And so in here, I gave you kind of a list of some common Pythagorean triples that you will see. The ones here in bold are the 4 common ones. The ones underneath them are multiples. So for instance, 3, 4, 5 is the one that Pythagoras started with. And with the 3, 4, 5, if you multiply it by 2, you get a 6, 8, 10. If you multiply it by 3, you get a 9, 12, 15. If you multiply it by 10, I get a 30, 40, 50. 5, 12, 13 is another one, 8, 15, 17, and 7, 24, 25. So when I am trying to come up with quiz questions or test questions or ask you different scenarios, I start with those triples if I want to make sure that your answers are going to avoid fractions. If I don't care if your answers avoid fractions, then I just pick any random numbers that I have. So if you remember last week when we were doing do these numbers make a triangle, I said we're going to be adding in one other little detail. And so here's that other little detail. Not only can 3 numbers form a triangle, but we can also test them to find out if they form a right triangle. So if you remember to test numbers to make sure they form a triangle, we add the 2 smallest numbers and they need to be greater. Can't be equal, can't be less. If we determine they're a triangle, we then can test them to see if they're a right triangle. And when they would make a right triangle is if you put the largest number in for C, the 2 smaller numbers in for A and B, if we get an equal ratio or an equal comparison, then it's a right triangle. If it doesn't come out equal, then it's not. You can actually take this one step further, and if C squared comes out greater, it will be obtuse. If C squared comes out less, it will be acute. That's something that I always make my honors class take it one step further, but for us in this limited environment, I'm not so concerned. It's really all about the SOL only cares about you being able to determine if it's a right triangle or not. So what I have is these problems down here. So I have 4 different examples in which I want to know, first, does it make a triangle? If the answer to the making a triangle is yes, then I want you to test if it makes a right triangle. If the answer to is it a triangle is no, then we're not going to test for it to be a right triangle. So is it a triangle? If I take the two smallest numbers, so essentially your A and your B in this case, take my two smallest numbers, 3 plus 4. Is 3 plus 4 more than 9? So you're going to take 3 plus 4 and you're going to compare it to 9. 3 plus 4 is 7. 7 is less than 9. So that is a no, not a triangle. If it's not a triangle, then it can't be a right triangle. But when I go to number 2, if I try 15 plus 20, that's 35. 35 is definitely, and this was meant to be like a comparison bubble. If I'm comparing it to 25, I would say 35 is greater than 25. So yes, it makes a triangle. So now that I know it makes a triangle, I want to take these numbers and put them into a squared, b squared, c squared, and find out if it works. So I know that my two smallest are my a and my b. My largest is my c. So I have my 15 squared and my 20 squared, and I have my 25 squared, and I want to add these together, and I want to do my 25 squared. 25 squared is 625. 15 squared is 225. 20 squared is 400. If I add them together, I get 625. If these come out equal, it's yes. It's a right triangle. If they don't come out equal, then it's no. It's not a right triangle. Okay? Let's try this one. Is 5 plus 6 more than 7? Well, yes. 11 is greater than 7. So, yep, it makes a triangle. Does it make a right triangle? So if I do 5 squared plus 6 squared, does that equal 7 squared? 5 squared and 6 squared, so that's 25 plus 36. 25 plus 36 is 61. 7 squared is 49. 61 does not equal 49, so that's no, not a right triangle. Over here, you try the last one. So take a minute, try the last one. So in the last one, 12 plus 16 is 28. 28 is more than 20, so that's yes. So it is a triangle, so then I can continue testing. 12 squared plus 16 squared is 144 and 256, which is 400. Does that equal 20 squared, which is also 400? Yes, it does. So this is a triangle and a right triangle. So that's how you test if it's a triangle and if it's a right triangle.